In this video we're going to discuss the discriminant. Now the discriminant is the part of the quadratic formula that's inside the square root. So that's this section here. And what this does is tell us how many roots we are looking for. So just to give you a reminder of what quadratics do, if we have a graph and we draw a positive graph, a positive x squared, then the points where it crosses the x-axis are your roots. So in this case I have got two roots. And we call them two real and distinct roots. I'll come back to the wording on this. Now if we'd had the same line and it came down and just touched and went back, and it just touched at one point, we would say that we had one real root or two equal roots. And if we had one that didn't touch the x-axis at all, it has no real roots. Now, if you're busy filling out the formula and you come across one that is impossible to answer, that's because there are no roots. The quick way to find if there are any roots is to use the discriminant. So, this bit here, b squared minus 4ac. If this gives us a positive answer, bigger than 0, then we have two real and distinct roots. If we get a negative answer, smaller than 0, we have no real roots. And if it equals 0, we have one real root, or, if you prefer, or two equal real roots. Now if you get an answer which is negative, then you're going to get no real roots and there is no point continuing with the calculation. Let's have a look. So let me give you an example. If we have the equation x squared plus 7x plus 3 equals 0, then just like before, we know our a, b and c values, our a, b and c, and we plug them in, but this time just into the discriminant. So our b squared is 7 squared, and it's take away 4 times our a, which is 1, and our c, which is 3. So 7 squared is 49, take away 4 times 1 times 3. So 4 times 3 is 12, and times them by 1 changes nothing. So this gives us a discriminant of 49 take 12, which is 37. So that would be what went inside our square root sign, and you would continue on with the calculation because you've got a positive answer, unless the question only asks for the nature of the roots. This bit is the nature of the roots. Now, what about if we have x squared plus 6x plus 9? In fact, let's make that 3x squared plus 6x plus 9 to give an example of what would happen with a positive, with a value greater than 1. So our b is 6, so b squared is 6 squared minus 4 times our a is 3 and our c is 9. So 6 squared is 36, take away 4 times 3 is 12, 12 times 9 is 108. Now you can see here 36 take 108. I'm going to have a negative score here. My brain's just shut down and not telling me what it is, but I'm going to have a negative score. I think it's minus 72, but don't quote me on that one. It's a negative score, so we know we have no real roots. So the nature of the roots here is we have no real roots. Now, if I use the same numbers but change that back to the original x squared, because this is the example in the book, if that, I should have equal to 0 at the end there. If we take the discriminant on this, we have b squared is our 6 squared minus 4 times our a of 1 and our c of 9. I don't know why I bothered putting equals 0. It's not necessary. Right, so 6 squared is 36 minus 1 doesn't change anything, so 4 times 9, which is also 36. So that gives us 0. And with that, it tells us we have one real root. So it touches at one point. Now, it doesn't change anything for where that point is. If we were to follow this through and put it back in, we would have x equals minus b plus or minus the square root of 0, which is 0, all over our 2a. And if we put our numbers in, we have x equals minus 6 plus the square root of 0 over 2 times 1. And we have x equals minus 6 minus the square root of 0 all over 2. Tidy that up a little bit since we know that root 0 doesn't exist. It's 0. We have minus 6 over 2, which is minus 3. And we have minus 6 over 2, which is minus 3. As you can see, 2 equal real roots, or 1 real root. Thanks.